Hello friends, welcome back to my channel and let's go through an interesting problem involving amplitude modulation. The problem statement goes like this. We are given the modulated signal given by S of t is equal to 𝐴cos 400 pi t plus 𝐵cos 360 pi t plus 𝐵cos 440 pi t, and it is given that carrier power is 50 watts and the ratio of total sideband power to the total power of the AM signal to be 1 by 9, and we are asked to evaluate the value of B. So let us proceed. Let's A typical AM signal is given by this form, which is S of t is equal to A plus M of t times cos 2 pi FCT, where A is the carrier amplitude, M of t is the message signal, and FC is the carrier frequency. And what about the given signal? The given signal is this, which we already saw, which is A cos 400 pi t plus B cos 360 pi t plus B cos 440 pi t. Now let us represent this given signal in the above form. To do that, we will apply the trigonometric identity, which is given by cos C plus cos D is equal to 2 cos C plus D by 2 cos C minus D by 2. So using this identity, we get the second, but we've used this identity on second and third terms in this S of t, which is given where we take B out and we get cos 360 pi t and plus cos 440 pi t. Here C is 360 pi t and D is 440 pi t, and by using this identity we can get this formula, which is given by A cos 400 pi t plus 2B cos 400 pi t times cos 20 pi t. So what is that we have got? We have got S of t in this format, and that can be written in this form where we took cos 400 pi t common. You get A plus 2B cos 20 pi t whole multiplied with cos 400 pi t. Okay, comparing this with our standard AM signal, which is given by S of t is equal to A plus M of t whole multiplied with cos 2 pi FCT, you see that message signal M of t is nothing but 2B cos 20 pi t. We can call it modulating signal also, and also we see that carrier frequency is given by FC is equal to 200 hertz. Why? The carrier frequency in omega in radians per second would be 400 pi and in hertz would be 200. Why 400 divided by 2 pi would be 200 hertz. Yes. So for a given AM signal or for a typical AM signal given by S of t is equal to A plus M of t cos 2 pi FCT, the carrier power would be equal to PC, that would be equal to A square by 2, and message signal M of t will have a power of PM and the sideband power would be PM by 2. Sideband power denoted by PS would be equal to PM by 2. Okay, and total power of the AM signal for S of t would be equal to it is given by PT, and that is equal to PC plus PS, where PC is the carrier frequency and PS is the sideband power. Okay, yes, here PC is the carrier power and PS is the sideband power. Okay, now let us go back to the signal which is given. So for that, what is the carrier frequency? We don't know A, and hence let us have carrier frequency to be A square by 2. And what about the message signal? Message signal is 2B cos 20 pi t. So this is a sinusoidal signal. For this, power would be equal to square of the amplitude divided by 2. So here the amplitude is 2B, and hence we have to square it, which is 2B whole square, and we have to divide it by 2. You get 4B square by 2, which is equal to 2B square. And what about the sideband power? Just now we saw in previous slide that sideband power is equal to PM by 2. So here we got PM to be 2B square, and hence PM by 2 would be B square. And what about the total power? Total power is nothing but PT, that we saw that to be equal to carrier power plus sideband power. So here carrier power is A square by 2 and sideband power we got to be B square, and hence total power would be equal to A square by 2 plus B square. Okay, and what about the problem? The problem statement says that carrier power is given to be 50 watts, but we know that that is equal to A square by 2, and also the ratio of sideband power to the total power is 1 by 9. Okay, so we got PS to be equal to B square in the previous slide, and we have seen that total power Pt is equal to a square by 2 plus b square. So let us substitute these two terms in this. What do we get? So ps is replaced with b square and pt is replaced with a square by 2 plus b square. But if you remember, is or you see that here a square by 2 is given to be 50. So let us substitute that. We get this term would be equal to b square by a square by 2 replaced with 50 plus b square, which is equal to 1 by 9. So by simplification, you see that you take cross multiplication, you get 9b square is equal to 50 plus b square. Okay, so if you cross multiply, you get 9b square is equal to 50 plus b square, but 9b square minus 1 minus b square would be 8b square. So from that we get b square to be equal to 6.25, and if we take square root of that, we get 2.5. So we get the value of b to be equal to 2.5. Okay, so in this problem, what did we do? We explored the concept of amplitude modulation. In this, few parameters are given and few parameters are asked to find out. Hope this problem helps you in understanding a bit of concept of amplitude modulation. Thank you.